We have some vocabulary. A lot similar to what, obviously? A circle, right? A lot of the vocabulary it comes from the circle that we've already talked about, and you know pretty well. But still, just like in our circle, it's a set of points. The same distance. Oops, I forgot same. From the center. So just kind of like our circle, right? And then we have everything that we had in a circle. So what were some vocab words we had in our circle the first time? Yep. So we still have a radius. We still have the diameter. We still have chords. Okay. Tangents. So you know what all those are? Radius goes from where to where? The center to the outside? Straight through it. So it touches both sides of the circle, but it's got to go through the center. So what's the difference between those two? Yeah, so a chord has endpoints on the edge, and then a tangent. One time, right? And then there's a secant too, and what's a secant? Touches twice. So same vocab we can have from a circle, we can have in a sphere. All right? One of the things that we will introduce in this is something called a great circle. What do you think the great circle is of a sphere? The middle, right? So if you took a ball and you again had a samurai sword and you lobbed that ball up and sliced it right down the middle, what would you say about the great circle? What has to be true about that great circle? What? Well, yeah, you read that. But what has to be? So think about a ball. If you took your baseball or your softball or your basketball or whatever ball that you had, and you sliced off towards the top, and you looked at it, what would you see? You'd see a circle, right? On both sides, right? The piece that I chopped off. Now, if I chopped it off right down the middle, would I still see a circle? And what would be the difference between that circle and the first circle that I looked at if I just chopped off the head of the ball? It's bigger, right? And if I chop it straight down the middle, what has to be true about that great circle? Exactly. So the great circle is splitting the sphere in half at the center. This is the biggest circle in a sphere. And if we cut it dead in half, we would call each half a what? Okay, it's going to cause a semicircle, but we would call it a what? Think about the globe. A hemisphere. Awesome. So this splits into two hemispheres. Hemisphere. Yeah? And as Miss Hine intellectually knew, the endpoints for this that went through the center are called poles, if you wanted to know that. Yeah? So we talk about the surface area then. So what's the surface area again? It's the amount of what? Where is the surface area of an object?
On the outside.
On the outside, all the way around the outside, right? So if you think about all the way around the outside, it's got to revolve around the circle, right? But then you got to take into effect how many circles are actually in a sphere. Well, there's a lot of them, right? We could realistically keep chopping it and see a bunch of circles. So they did a bunch of math for you already, and they came up with the surface area as being 4 pi r squared. So if this is what my surface area of my ball is, now think about chopping that thing right down the middle at that great circle. And so the next one we're going to talk about is the surface area of a hemisphere. So if my surface area for the entire thing was 4 pi r squared, what would I have to do to 4 pi r squared? I'd have to divide by 2, right? Because I'm cutting it in half. So my 4 divided by 2 is really going to make this 2 pi r squared. Everybody agree with that? Now, what else do I have to consider with a hemisphere? The circle on the bottom, right? And so basically, what's the area of just one circle? Pi r squared again, right? So we're going to add another pi r squared because this is really the great circle on the bottom. This part would be the kind of ball-shaped part. And so realistically, if I simplified this, I would actually have what? 2 pi r squared plus 1 pi r squared would give me what? Three pi r squared. So the surface area of a hemisphere ends up being 3 pi r squared. Okay with that? And again, we're just combining basically my bottom of my ball and then the rounded part of the ball. Okay, so then leads us to the volume of the sphere. And again, the difference here is this is how much I can fill up the inside of my ball with something, right? That's what volume means. And so basically, if you think about volume as a portion of the surface area, so we want to include the surface area, and then we're going to think about the volume of a right pyramid. Do you remember what that was? Obviously, if you look up here real quick, it's 1/3 base times height. Okay, so we're going to combine those in a sense. We're going to put them together because basically it's both of those in one little thing. And so if you look at this, and you notice the h here and an r squared, well, the radius of a sphere is like the height in our pyramid. So realistically, my h and my r squared are the same thing. Okay, so if I take and change this into an r right here, what would I have if I had r times r squared? R cubed. And if I took 4 times 1/3, I'd get what? What's 4 times 1/3? 4/3, right? So my volume of a sphere, combining those two things, is 4/3 pi r cubed. And that's how they come up with that. And so again then, if I thought about my hemisphere, what am I really doing to my ball again? I'm cutting it in half. So if I take my last volume that I just talked about, what would I have to do to 4/3 pi r cubed? I divide it by 2, right? So realistically, to get to there, I'm going to take 4/3 pi r cubed times Merrick said divide by 2, but dividing by 2 is the same thing as multiplying by 1/2, right? And so, if I notice my 2 and my 4 cancel each other out, what's left over? 2/3 pi r cubed. And we get our answer. Okay? So all I did here was basically take my volume of a sphere, chop it in half, divide by 2, or multiply by 1. And we get our answer. Okay? So again, notice 1, 2, 3, 4 more equations. Right? So a big part of this test is going to be equations. Come Monday, I believe I'll give you a sheet that has all of this on it. So you have a sheet to study from. And no, you don't get to use it on the test. Okay? All right, let's check them out up here. Any questions with the words? So, first one, find the surface area of a sphere around to the nearest tenth. Again, make sure that you realize that it doesn't matter what I use for pi. You can use the button, I can use 3.14. That doesn't matter to us. All I really need is my radius, right? So again, if it's surface area, I'm just popping it into my formula. Don't forget that it's r squared times pi. So I got to take 4.5 times 4.5, then times pi, then times 4/3. Again, now if you're thinking about, times 4. Volume is 4/3. So, anybody need to see the real math? Well, we can show you this real quick, I guess. So, obviously we're just punching all that into our calculator. Okay? But don't forget to square the 4.5. Don't square everything, just the 4.5. Okay, and then again, we're doing surface area. So what's my label? Inches squared. Surface area, it's an area, so we go back to squares. Okay? Good with that? The one I want you to see, they start talking about. So then we get a hemisphere. So basically, we're doing the same thing. We just move over to 3 pi r squared. Pretty similar, right? Again, though, it's still surface area, so we're still millimeters squared at the end. Everybody good with that? So again, nice and easy. Okay? They still did it the other way without reducing it. I'm just trying to help you out here to reduce it. It's way simpler, I think, if you just look at it as 3 pi r squared than that. You know what I'm saying? So, here's one. Find the surface area of a sphere if the area of the great circle is approximately 220 square meters. So what does that mean to you? What does that help us? Or why do they give us the area of that great circle in order to find the surface area of the whole thing? I'm going to find the radius, right? So, what is the area of a great circle? Or the area of a circle in general? Pi r squared again, right? So, I would take pi r squared and set it equal to my 220, right? Because that's the area of this circle. And I need to find this radius right here. So, the first thing I'm going to do is put pi r squared is equal to 220 and then solve. So if this is my equation that I'm working with right here, how do I get r all by itself? Divide by pi, and then what? Take the square root of both sides. And you got to do it in that order. Okay, so they get approximately 8.4. Again, what I find interesting about this book and these examples all the time is they kind of preach about not rounding, and then they round it right here again. So again, I wouldn't go and round any of it. Theirs is probably off at the beginning because they said this was approximately 220. So that's not the exact answer either, but we live with it. So we find our radius, and then once we find our radius, Now we can go back and do our surface area formula. Okay, so we put 8.4 in as our R, and we're right back to what we did in the first example. That makes sense to everybody? So here's my formula again, and again, make sure that you square it before you multiply by any of the other things. I think we already did that one. So how about this one? Find the surface area of a sphere if the circumference of the great circle is 2 pi. So when they say circumference, now we just got to change gears in our head, right? What's the circumference formula for a circle? Pi d or 2 pi r, right? So again, the first thing that I'm going to do is try to find my r, because my r is what I wanted here for my surface area, right? So if I'm going to write this out, I would say, and again, you can use pi d, but I'm going to use 2 pi r just because I know that I want an r. So I'm going to say 2 pi r is equal to, and then they told me that this was 8 pi. So this is realistically a little simpler if they keep pi in the problem, because how do I get r all by itself? Divide by 2 pi, right? And if I divide by 2 pi on both sides, what's r? That one's an easy one, right? So r is 4. And then I would go back and I would punch it into my formula again. So 4 squared is 16, roughly 16 times 4 is 64. Whatever 64 pi is my answer. Correct? Okay? Discard. Already did that one. So then we go into the volume, and you just have to make sure again what you need. So find the volume of the sphere with the great circle's circumference of 30 pi. So just like Cameron said before, we're going to use that circumference to find our radius, and then once we find our radius, we just plug it into the formula. So the biggest thing here is, do they give me a circumference or do they give me an area? And then I have to make sure I take that and put it with the right formula. So if it's an area, it's pi r squared. If it's a circumference, it's 2 pi r or pi d. Again, you can always use pi d, but if you use 2 pi r, then you have your radius right there with it. Okay? And then the biggest thing is making sure that these two right here are squared, these two right here are cubed. Because it's still a surface area and it's still a volume. Do we need to look at the math of this one? Sure. You guys are, it's Friday. You can be happy. Excited. It's Friday and you're doing math. What 2 better things can you ask for? Huh? What are better things than that? Okay, how about this one? Find the volume of the hemisphere to the nearest tenth. Again, they don't really tell you exact, but the first thing I would do with 80 meters is what? Divide by 2 to make it into a radius instead of, okay? The last one I want you to do or make sure of is, I think there is a couple story problems today. Okay, so again, just identify what you have and identify what you are asked to find. So again, you have to differentiate between circumference, area, volume, surface area, and then diameters and radii. So make sure you go slower as you're reading through the problems and you get the right information that you need. Okay? You guys are killing me. Mr. Alice wants to come in and see you guys next week every morning. I said, you're going to be real impressed with first period. Why? Why would he be impressed? Because you guys are like zombies. What? Oh, sorry.